We'll practice solving a perfectly inelastic collision problem. Here's the problem. A 3.0 kilogram cart moving at 4.0 meters per second collides with and sticks to a stationary 2.0 kilogram cart, a perfectly inelastic collision in one dimension. Part A. Find the common velocity after the collision. Part B. Find the kinetic energy lost in the collision. First, use conservation of momentum. Since the carts stick together, the total mass after collision is m1 plus m2. Momentum before equals momentum after. m1 v1 equals the sum of masses times the common velocity v prime. Solve for v prime. V prime equals 3.0 times 4.0 over 3.0 plus 2.0, which is 12 over 5.0, given 2.4 meters per second. Now calculate the kinetic energy before the collision. Kinetic energy initial equals 1/2 times 3.0 times 4.0 squared, which is 1/2 times 3.0 times 16, giving 24 joules. And the kinetic energy after the collision. Kinetic energy final equals 1/2 times 5.0 times 2.4 squared, which is 1/2 times 5.0 times 5.76, giving 14.4 joules. The kinetic energy lost is the difference. Delta Ke equals 24 minus 14.4, which is 9.6 joules. In a perfectly inelastic collision, momentum is conserved, but kinetic energy is not. The lost energy is converted to other forms like heat or sound.